All right, welcome back, everyone, for our very final session before the reception. Okay. All right, so I'll go ahead and introduce the last panel for today. It is Driving Confidence in Insights from Digital Twins. And your moderator is, of course, Andy Smith. We all know and love him. And so take it from here, Andy.
Good afternoon, everyone. If we can get our seats and we can get underway, that'd be great. Not so many in here now. Probably a few people like me who need a nap, a cup of cocoa, whatever it is. Right, so we're going to talk about driving confidence in insights from digital twin. Fantastic panel today. So we've got Jennifer Rebeiro from Greater Western Water, Australia. Agnethe Pederson from VCS Denmark, Jim Cooper, who's Global Director of Water and Optimisation from Arcadis, and Elijah and Alyssa, who are going to talk to us about the work that they've been doing in Greensboro. Okay. So what we want to do is use some technology. So if you look at the screens, you can see on the platform and also on the mobile app that we've put a little red square around a poll question that we want you to answer, if possible, okay? So that will go live. Is it live? Yeah. So it is live now. So if you could go on to that, answer the question, and then we'll come back to it right at the end and see what your thoughts are, and hopefully we'll start to move as we go through, okay? Right, so we're going to crack on. And we are going to get James up first, who's going to talk to us around the work that he's been doing with the AWWA Digital Twin Committee.
Good afternoon, everyone. Good afternoon. Great. So I'm going to talk to you about the relatively new Digital Twin Committee for the American Water Works Association. I'm the first presenter, so I guess I can spend the next 45 minutes talking about that, and we can go to Q&A now. So let's start out with what do we spend the most of our time today as water professionals, right? I think it wasn't that long ago when the greatest amount of our time was consumed by taking ideas that we have and putting them to paper and making them digital, right? And then all of a sudden CAD came along and BIM and GIS. What took weeks and months maybe now takes days and hours and even seconds, right? And not only are we taking those ideas and putting them in the digital environment, it's even being automated today. I think the greatest challenge we have is the amount of time we spend trying to find data, understand the data quality, make use of that data, and turn it into information and insight, right? So we're talking about digital twins. Let's think about what it would take to spend more time getting back to engineering and getting back to operating and less time swimming through that data lake. So I like to ask this question: how much more data could we possibly need? Are we at a point where we're just oversaturated with the amount of data that we are collecting and is being produced in the water sector? Or are we, is there more to go, or is there more data we're going to be collecting? I think we're only beginning in the amount of data that we're going to be collecting in the water sector, right? So we've heard lots of use cases about digital twins. We've heard, many different benefits, right? I'm not going to talk about the use cases and benefits that the committee is coming up with, but let's think about when we have double the amount of data that we have today that we're collecting, how are we going to manage that, right? How long will it be from the frontline staff where you have a question like this, where I cannot operate or manage any individual asset without a live data stream on that specific asset, right? And I'm not talking pumps or tanks, right? Think about individual sticks of pipe, for example. So we think about data. We think about how we can process that data. A lot of times the thoughts come up of, oh, we're going to use AI, we're going to use machine learning, and it's just going to be this magic thing that gives us all the answers we want, right? I think we couldn't be further from the truth with that. AI is not here to replace our people, right? AI is not here to solve all our problems. I think it's truly here, and we get the benefit of it when we allow our people to be enabled by intelligence and digital twins. So I have a couple definitions up there. I define AI as the ability of machines to sense, reason, engage, and learn in a manner that seems intelligent. I think you need to have all four of those together to make AI. If you have machine learning, that could be a component of it, but machine learning alone, I don't consider AI. That would be the same as getting 4 brand new tires and saying, hey, I've got a brand new car, right? On the other side of it is the idea of collective intelligence, allowing people to directly interact with technology and collectively coming up with a solution. And this is not some great idea we came up with. So it sounds great. There's a whole center at MIT focused on this. And in all their experiments, every single time when the people and the technology directly interact, you get a better solution every single time. That's where digital twins fit in my opinion. So digital twins, right, we've talked a lot about them. I think that when you think about digital twins, it can be confusing if we all talk about a term digital twin and think it means the same thing. I think we need to break it down. We need to look at the readiness guide that just came out. We need to look at, are there different levels of maturity for digital twins? Are there different types of digital twins that you could possibly have? Now you can dive into the details, and some of the work that I've done looked at, what's the different levels and what's the value you get out of different levels of maturity of twins and what's the different requirements, right? I'm not going to spend too much time on that. I really want to focus on the AWWA Digital Twin Committee. So back in 2020, a work group was formed from a number of members of AWWA that said, hey, we need to talk about digital twins. And by the way, SWAN's doing great things in digital twins. We should make sure we collaborate with them, right? We should talk with other organizations as well. So that was back in 2020. In 2021, it was formed as a formalized committee within AWWA. Today, there's 3 subcommittees and currently have over 150 active members. So it's rapidly grown as a really great powerhouse of industry leaders in that. If you see the mission statement there, it's focused on developing educational guidance, building consensus on terminology. Gigi mentioned this morning the definition, the unified definition that the committee collaborated with SWAN to develop, and collaborating across all organizations that are focused on this. I really encourage you, if you're a member of AWWA, to join that as well and continue collaborating and joining that conversation. There's a lot of content out there that the committee's prepared. Many of you in this room have helped prepare that. Our Articles and Publications subcommittee is chaired by Brian Skeens, and he's been doing a great job developing and building a pipeline of content that's coming out within the American Water Works Association publications. Are we swimming through a data lake? I think we're really only just diving in, and we need to be prepared for what technology and solutions we're going to use to enable us to leverage that data we're going to be collecting. With that, thank you for your time.
We're now going to move on to Agnethe, who's an environmental engineer with 10 years experience as a hydraulic modelling expert in urban drainage models. In the last 3 years, she's done an industrial PhD and just handed in her thesis, so congratulations for that. She's researched the methods to gain trust and transparency in digital twins by analysing model results against observations. So we'll hand over to you, Agnethe.
Yes, thank you. And I hope that some of you are more into the technical stuff because it will be a bit more technical. And I hope that you will like it, or else you just relax. We had a great discussion just an hour ago in our roundtable where we had this discussion of do we trust the model? And how can we trust with the data that comes in? And it just fit into my presentation, so I hope that at least one will enjoy it. Because what we need was that we are using our hydraulic models, the simulation models in the digital twins, for a lot of stuff. among others, the designing of or deciding which pipe size that we are going to put into the ground, and those cost a lot of money. So of course, there's a lot of value here, and all of this is based on what is the output of this simulation models. But do we really know what is the confidence in these simulation models? So I have a digital twin where I have the physical system, where we have a lot of asset data, as you can see on the figure to the left. And on the right, we have the simulation model, which are an entirely physics-based model. We do not put any data simulation. We do not feed data into this physical system or physical model, and I will explain you why we don't do it just in a minute. And just because I'm from the lifecycle group, this is an operations system level digital twin where we have an output, as you see, with the time series. And we have a lot of observation sites in our system, and we thought, why don't we use them? They are used for other purposes. Why can't we just use them also to gain trust in our simulation models? So we have these different digital twins. We have the living, where we have the control and operation. That's where they should replicate the reality. And then we have the prototyping, where we have an offline version, and we try to make a scenario, what is going to happen if we put in this space in, or if we do that. So we try to do that things, and that's where all the, at least in the investment side, we have all the money is put. But we cannot learn from these prototyping digital twins. We can learn from the operation model, so we can learn what is going on in the reality. So we have all the observations, and if we have a model simulating this system, we can extract the knowledge and put it into the prototyping models, and thereby hopefully save money on what is going to be put in the ground. Yes, and that's why we don't use data assimilation, is because if we are starting to use data assimilation, it's fair enough to have a model where you put in data assimilation, but then you cannot use it for the purpose that we want to know what is the performance of the system. So I have written a paper about this. You can read it. It's free and online. So I want a system that I can, in my digital twin, I can figure out, is my model performing well for different objectives? Because should the model perform well for all objectives? Somebody says, yes, it is going to be well for all objectives. Maybe it's not. Maybe it's not on all sides. So I identified some model objectives that I investigated during my PhD. For example, this everyday events, where the water level, it will not rise above the top of the plus forwarding pipe. So that's one objective. That's the everyday event. And we can also have the overflow event, where it's only the events where the water level will be above this crest level. So there is two objectives here that we were going to investigate if our model performs well. And the way I do it now, this is maybe the hard part, and I will go briefly over it because I only have 7 minutes, and that's not a long time. And I'm going to present this at my thesis or my defense in a month, more into details. But it's all about these signatures, the graph in the middle, that we have all the events, and we can extract properties from these events. For example, the peak level, the AUC, which is the area under the curve, or the duration. We can extract these things, and some things are more important for the overflow, and some of the signatures, the extractions, are more important for the everyday event. So first of all, if I look into the overflow, you can see here that's all the events in the gray area for the peak flow, but the peak flow is not interesting for this objective. That's the duration above the crest level, and also this AUC. That's the important signatures. The rest doesn't matter for this objective. And so you can do with the everyday event. There is a lot here. I will not go into details. But you can analyze all of this, and I will not explain you all the magic. You will have to wait till I publish a paper or come to my defense. So magic happens, and then I get a map, and this is a really nice map, I think. So this is my everyday event. So if there is a green color here, and there's a lot of details on it, but green, good, yellow, less good, and red, you're really doing a bad performance. So what we can see here is that we actually are doing very well for some areas, and quite so good for other areas. If I do the same for the overflow, you can see that we actually performing a lot worse in the lower city, where we have a very red area. So we actually cannot use the overflow calculation or the overflow, the model output from this overflow for this area. It is kind of frustrating, but it's not surprising. But it's annoying when I'm using my model for these extreme events like the overflow and the surcharge situation that my model is not good enough. But I have the insight now. And then you can ask, why didn't you just calibrate it? I have several reasons for that, and you can read that in a published paper also. I will not go into detail with that. I'm really passionate about this, but I will not tell you. You can come and ask me. But we are going to implement this in our utility. This have been done for the 2 case areas in my PhD study, and now we are having done halfway of implementing all of this, where we have about 400 observational sites for our tiny utility of 250,000 customers. So it's not very big, and we have 165 sites where we have water levels where I can use my method to make this model performance. Yes, that was that.
So thanks for that. I'm pretty sure we can make a room available for you on the side somewhere. So if anyone wants to actually read the papers, go through those with Agnethe, that'll be fine. Right, so we're now going to hand over to Alyssa and Elijah Williams. So Alyssa is an associate of Hazen and Sawyer, professional engineer with 10 years experience in wastewater process evaluation and facility design, currently specialising in wastewater treatment process modelling. And then we have Elijah, who is the water reclamation manager in the Department of Water Resources at the City of Greensboro. Thank you. I'll let you go.
Thank you for having us as part of this session. Our project that we worked on starts with the expansion of the TZ Osborne Water Reclamation Facility. We were looking at, for the City of Greensboro, going from 2 wastewater treatment plants, TZ Osborne being 40 MGD capacity plant and North Buffalo facility being 16 MGD plant. And because of the more stringent limits, specifically in total nitrogen, it made more fiscal sense for us to go to 1 plant. With that, we were going from a regular activated sludge process to an advanced BNR 5-stage activated sludge process to deal with the nitrogen. And with that, all of our institutional knowledge was going to be going away because we were going to be essentially treating a different way with our main biological process. As we started going through, we saw a significant increase in BOD loading over the years from when we started, maybe back in 2010, 2011 to the time we got close to construction for the final phase in 2016. So Hazen was able to leverage some of this modeling in the background. We started also talking about training, and that's when the idea came up as far as maybe doing a digital twin to help with our process of changing from the old way of treating to our newer process of the 5-stage.
Yeah, so the goal of this project was to create a tool that was based on the calibrated process model that we had been using in the preliminary and detailed design to then move into the next phase, right? Startup through construction and to train the operations staff. So the goal was to leverage that model, and there were kind of three parts. We wanted to be able to accurately represent the new secondary treatment process. So going from that kind of 2-stage phosphorus removal process now to a 5-stage to do both TN and TP removal. To train the staff on this kind of shift in philosophy now to balancing both the TN and the TP removal. And then also to empower the staff to use the tool moving forward. So to continually optimize the process even after startup. So, we started with this training piece in construction to kind of give the staff an opportunity to kind of understand what was coming. And then through startup to optimize the process through nutrient removal, aeration strategies, et cetera. And also planning, right? Asking the questions of, okay, well, I've got this tank out of service due to construction. What mixed liquor do I need to run at in order to maintain my treatment? So all those were things we wanted to help answer questions and give staff resources to be able to optimize their system. And so we worked on developing this digital twin, starting with the site-specific calibrated model in Sumo. This is based on a recent set of historical data calibrated to match solids production, nutrient removal performance, overall treatment. And then on top of that is a customized interface that reflects the plant layout. So like a clickable aerial image that was easy to navigate, get to different inputs that operations staff might change or might be interested in looking at. But also with a focus on the aeration basin configuration, the new layout with respect to their nitrified recycle pumps, the different DO regimes they might have throughout the process to allow them to do this kind of what-if scenario evaluation. And then on the output side, we're visualizing the effluent quality, as you can imagine, also seeing profiles in the basin of what's kind of happening throughout, and then key operating parameters they were interested in. And this tool was set up for a steady state simulation to start. There's an interest in keeping the simulation time very quick so that they could, in the training environment, have quick what-if scenario evaluation. But the infrastructure of the tool is really set up to expand in the future to, dynamic simulation or linking to other tools, et cetera.
All right. So as far as implementation, user buy-in was definitely encouraged from the beginning. How we looked at this from day one was it being a tool to help the operations staff understand the new process better. As the tool was being developed, we was able to have sessions and workshops where we were able to talk about how the tool was working. We would be able to mess around with the tool. My maintenance superintendent put enough data in there to actually break the tool, not literally break it, but have it spinning indefinitely until you have to start it over. So that was pretty cool, and it gave us the opportunity to really give input into what we were looking for, and so different things were changed, and we eventually came up with a web-based application that we could work off of and use, and it's been a really good tool for us, and we'll talk about it next slide, some of the status of what we've been doing. So as we started bringing in the new basins and started looking at the 5-stage, we used the tool as hey, let's look at the first step of migrating from extended aeration and I know that everybody is from different areas, but from the old way of doing things to the new way of doing things. So we slowly started bringing processes in and making changes and going through the different zones. And we would make the changes first in the digital twin, look at it, talk about what we should see. Then as we would see those things happening, look at the data that we were getting from our testing and analytics and, with our lab, it was really good to give confidence to our staff that what we were putting in was going to work. The digital twin was able to do its job and to give us the confidence to move forward into 5-stage. We had to be in full compliance by 2021. We we did meet that. And as you can see, as we went through, got better and better as far as our total nitrogen, as far as our removal. And we was able to meet our first year of compliance with the state. The tool also was used back when we had a upset at the plant. We had too many solids, I guess you would say. We had a solids issue, and we were able to go through and do some modeling that helped out with that situation as well. So I think to finalize, the next steps that we're looking at is to take the model. We're going to start looking at chemical usage, and we're going to also add some more pieces to the puzzle as far as what was built in the original model. We focused in on the aeration basin. We'll start looking at other areas, especially with chemical prices and everything going up. That's a piece I'm really looking forward to getting going to help us optimize some of those other areas. And because of the baseline that we had as far as the confidence we had in the model from the training, it'll make it easy for my staff to be able to use these tools for the next steps. Thank you.
Thanks, guys. That was great. Right, so moving on, we have Jen Rebeiro, who is the CIO, Chief Information Officer at Greater Western Water. And over the past few years, she's been focused on developing the foundational capabilities around data and analytics within the organisation, and was recently named one of the top 50 CIOs in Australia. In 2021, and in 2020 acknowledged one of the top 50 public service women in Victoria. So, welcome.
Thanks, Andy. So here I am, the last speaker of today about digital twins, and I'm here to say that at Greater Western Water, we don't have one. We're emerging and we're developing our capability set, but what we haven't done is actually take that leap into digital twin. And so when we had a chat about this today, in preparation for today, we really talked about, well, what's the journey that we've taken at Greater Western Water to actually discover our data and to discover our environment. So that's what I'm going to talk to you about today. And I've only got 3 minutes because I think I gave you some. So it'll be quick. So just a little bit about Greater Western Water. So Greater Western Water is the newest water utility in Australia. And so we merged on the 1st of July last year. So we're about to have our birthday celebration, our first birthday. And as if any of you have children, you will know that the first year of their life is very difficult at times, and where they're learning new things and discovering the world at large, and that's where we are at Greater Western Water. But by and large, we've actually done some really good things bringing the two organisations together. And importantly, it's about discovering what data we have and how we're going to utilise that data to inform some of the new things that we need to do over the course of the next 10 years. And one of the big things that we will be doing over the course of the next 10 years is delivering $3.5 billion worth of new assets. So that's a really big set of work program ahead of us, and we need the data to be able to help us inform that program as well. So in the absence of a digital twin, we still wanted to be able to gain some insights about what we're doing, gain some insights about our assets, and also gain some insights about our customers as well. But some of the major challenges, and I'm sure many of you, those who don't have a digital twin, will understand that data sitting in disparate systems all over the place, sitting in Excel spreadsheets, and also sitting with people who enjoy the power of holding that data to themselves, and therefore not being able to leverage that data for the greater good or greater information and decision making. So we needed to really think about how we were going to work with some of these challenges. And part of that first piece of work was to appreciate what was the platform that we were working with. And we had successfully implemented our Azure data lake like a data warehouse. So it was an awesome discovery where what we did is we spent a whole lot of money and implemented a reporting tool, which was a really fun learning journey that we went through. But what that meant was that we needed to re-architect that. We needed to say, what is the outcome that we really wanted to get out of the platform? You know, do we want to do deep analytics, you know, AI, ML, etc., and spent quite a bit of time on re-architecting that and rebuilding it, and I'm really pleased to say that we have done that, and we've been acknowledged from Microsoft as having one of the best architected platforms around. We just have to now use it properly. And the other part that we needed to do was actually really look at our capability. So we had not a lot of capability in the team. We were still using a lot external vendors to tell us and manage our system for us, which meant that we had delay and lags in getting some information through. And so that meant the business weren't necessarily happy with IT because we had to run scripts to get data and things like that. So there wasn't any real-time information, and therefore that was impacting evidence-based decision-making, and people were effectively still using gut to make decisions as well. So we built the capability. So we built a tech engineering team so that we could ingest data, we could curate data, and that we could actually start to bring different data sets together to give us some really good insights and to inform some of that decision-making that we were wanting to make about our assets, or that decision-making that we were wanting to make about our customers as well. And we started to actually know what our data sets were. And that's probably a really important part of this process, is that we actually went through a period of discovery as well. We also built capability in the team. So brought in resources, brought in Scrum Masters, brought in Agile delivery, brought in data scientists, brought in data analysts. So we federated the work across the business and had input data analysts out in the business so that we got close to the type of work that needed to be done, so that the centre, we have a hub and spoke model, so that the centre could really understand the deep analytics that needed to be done, and the data engineers could work with the cohorts to build out the capability set. So did I move that forward? No. So where are we? So we have our new platform. We're really happy with that. We didn't, what I didn't mention is that we didn't have automation prior. So there was lots of impost on the data engineering team. They would take a lot of time to ingest and curate and build out the data capability. But we now have those common tools, CI/CD platforms, processes, etc., to be able to ingest quickly and do the analytics fairly quickly as well. We're able to do some predictive work now, which is really great, and we're able to understand, potentially our job lives. So bringing in our programs, what's it costing us, doing, progressive assessment of that, and saying, oh, well, actually, this program looks like it's going to actually overrun, and it's going to either overrun on time or it's going to overrun on cost. And that's really valuable information that we could actually now work on quickly. We also utilised the predictive modelling for our hardship customers. So during COVID, a number of our customers weren't able to pay their bills. So we were able to proactively look at those customers and work with them on payment plans up front before they went into the shame cycle. And I think those of you who work with customers at all, when you're not able to pay your bill, it starts to become quite hard to engage with them many bills later. So what we're trying to do is get on the front foot and engage with them early as well. But most importantly, we have built an awesome self-managed team, a team that love and care deeply for each other, a team that will, potentially go and pick each other up from houses and hospitals and whatever. But they are a team that work as a really cohesive unit, really focused on the outcomes for the business. We've got the data, as I said before, the data engineers, the data scientists, the data analysts, and the business all actively engaging with each other. Where to next? Well, we may take a little step into some digital twins, but we are building a new wastewater treatment plant, and we're hoping that that will be a fully digital plant, and that will be our first big digital twin, but we may do some testing of the waters with some little twins along the way. And Gigi always asked the question about, is there one twin to rule them all? I'm not quite sure yet. I'm still waiting for the evidence to tell us which way to go. Thank you.
Right, thank you, everyone. Now we get down to the meat and bones of the questions. So it wouldn't be right for the panel not to answer the same question as the audience. So if we can go along quite quickly, and the question is, can we trust the insights provided from digital twins? So if we start on the far end with Elijah.
My answer would be yes. What I saw from using the twin in our training and getting acclimated to our new process is that with the right information and data being put into the digital twin and understanding the limitations, that you can get really good information from the digital twin to help you with whatever your problem or issue that you're trying to figure out. It worked well for us.
It's a good question, right? Can we trust digital twins? So I'm a proponent of digital twins, right? There's been great discussions and buzz about digital twins here today. I'm going to say no, right? I think it's really important that we don't take the excitement and buzz about digital twins and translate that to some magical capabilities that these are going to solve all our problems, right? If we keep it practical and grounded, and the term I like to use is trust but verify, right? So if we get to that point where we truly understand what twins can do, where they can fit within our organization, then let's verify, let's evaluate, let's build that trust as a part of developing the twin. But it starts out no. It's not a yes or no answer. It's a spectrum, right? No on the left, yes on the right, and you just constantly have to be moving towards the right. Otherwise, you're not doing it right.
Thanks. I would say absolutely. It's a continuum, so there is no yes or no answer. And trust is a really interesting word. So you have to define what trust means, and you have to define what your expectations are and the outcomes you're expecting. And if you're expecting 80% accuracy, well, that's great. You know what your accuracy rate is. If you're expecting 100%, you know what that is. Probably won't get it. You'll probably tell me that right now.
Yes, I think that you can trust, if you have the insights of your performance, then you can trust your digital twin. Maybe you will trust it to know that it's not performing well, but your digital twin you will trust. So it depends how you ask the
So
question.
yes to digital twins, possibly insight. Yeah?
Yes, exactly.
Okay.
Yeah, I think trust is earned, right, over time. So I think that there's a process, right, to building that trust with the twin. And so starting with something that you can prove out, maybe a smaller scale piece that you're working with that you can demonstrate over time, kind of like Elijah was talking about earlier, where we used it during startup, and in this particular case, which is wastewater process model related, right? You can prove out through your calibration and through testing and validation, kind of as you go, right, to feel more comfortable and trust it over time.
Great. So let's open it up to the floor. Any questions for the panel? Nothing? Nobody brave enough yet? Oh, there you all are. Wakey, wakey, everyone. So has anyone got any questions? I can go with some more stuff. So I'm going to ask you, Agnethe, around this question around then when is the insight provided good enough? And what is good enough?
Oh, and that's a tricky question because my research is also very limited to or narrow to some kind of type of sensors, and I think we should remember the big data, the 5 Bs or 4s or how many there are, that we need all the variety also, not only the volume. So I look into the water level sensors. Maybe we should put on the flow meters. Maybe we should put on a lot of other sensor types.
and we should learn from these insights, and maybe we should share them a lot more altogether, these insights, because maybe we can, nobody knows the simulation model of your utility. We don't know how it is done because it's very technical, and you provide your own and we provide our own, but we never compare what is the model performance of these. And I think that's necessary that we start to share a lot more data.
Okay. Any more thoughts from the panel on that one? Oh, we haven't got a question.
And everyone that has a question, go ahead and line up behind me. No question. No question.
That's what you need. You need a leader in the room because everyone will follow, yeah?
So I think next door we have another workshop going on. It's called Data as a Service. And I think data as a service, I'm asking a question actually. Data as a service and cloud computing, how is that going to change the landscape of digital twin in the future? And especially for smaller utilities or even some of the more established utilities, would you be able to deploy things much quicker? And will the idea of putting the responsibilities more on the vendor of the hardware, deal with all the IT and all the data cleansing, will that actually help digital twins in the future? So,
Anyone want to take that one?
Sure, why not? I'll take the bait. So I'm going to flip your question around, actually, right? I think a lot of us that are in the business, when we see something like artificial intelligence or digital twins, we try to say, how can that change the way we're working? How can we fit that digital twin into our processes, right? The few minutes when I presented, I was talking about the massive amount of data that's going to be happening, the amount of data that's growing. I think what we're going to find is that over time, it's just going to be a natural way of working for everyone, right? If we were sitting here 30 years ago, we might be talking about SCADA and distributed control systems, and people are probably thinking, oh geez, right, that what are our operators going to do, right? We're going to have everything coming to us now. It's how is that going to improve? Well, it just became a way of working, right? We could probably say the same thing about spreadsheets a couple decades ago. How many utilities operate based on spreadsheets and different equations that they have, right? I think digital twins is just going to be that way of working that we all just adopt to, right? It's when do we get to a point when it's not complicated to implement them? It's something that's simple and just as simple as taking a picture on your phone and then typing in something and you get that picture come up, right? I think we're getting to that point now where it's easily adoptable. And then when you get to that point, it doesn't matter the size of the utility, right? Or the maturity level of that utility. Everyone's just going to be doing it.
I also want to add that I think that we are going to have data as a service, software as a service, whatever as a service, maybe digital twin as a service. But it's also a balance. So maybe we will have it in for some parts of our system and some others. So it is a balance, and we for sure need to trust these services. But hopefully we will also have the tools.
So it's great. We've got them queuing up now, so it's even great. We've got one person queuing up for the mic.
Okay, I got a question for you. What do you think the biggest barrier is for digital twins? People, technology, or the availability of resources within a utility?
I guess I would say that it's been technology, because you have to find the right technology for whatever the issue is that you're trying to solve or work around. For us, it was finding the right base model, and from their interface, which I have no idea how they did all of that. But I know that the end product that I saw was very user friendly, and because of user friendliness of the end product or the interface, it enabled a wide wide variety of staff to use it with wide variety of education level, computer adaptability. So that's going to be key, because if you don't have the technology right to meet the needs of a wide variety of people, then you can't even talk about the people part of it.
Makes sense.
As the technologist in the room, I would say people. And predominantly that's because it's about trying to understand what outcome we're trying to achieve. It's trying to get trust in the system. And, I mentioned before, we still use our gut a lot in business. And so if our gut doesn't line up with the technology or the outcomes, who's right? And we know as humans that we can argue why the data is not right because of the extensive history that we have, and that in 1964 I've seen this problem occur before, and the data doesn't have that use case in there, so therefore you really can't predict the right outcome. So I would say it's the change management and the people. The technology part should be easy.
So maybe one quick comment on that. Generally, water utility innovation is, looking at dissecting that. It's all about the culture of the organization. One of the things that I've implemented dozens of digital twins across utilities, and one of the first steps that always comes up is, well, let's pilot it, right? And all the utilities are concerned about piloting the technology. Right? Well, breaking news, the technology is proven. You really want to pilot your people. How are they engaging with that technology? How are they using it? Those are the key things you really want to get to the insight to really get successful adoption of it.
And just my short answer is that I think we should balance it. It is not only the people, the process, or the technology. It's all of them. And if one of them is lagging behind, then the whole system is lagging behind.
Yeah, and I think just on the people side, that engagement early is, as Jim was saying, is a key component of building that trust, right? If people don't trust something, they'll never use it. And so that might be maybe a harder challenge to solve. Not that there aren't technological challenges, but more of this kind of soft side of how do you convince people that this is useful to them, right? You can't always do an ROI, right, on these things to prove like this is going to be a good tool for you. You need to prove it out a little by little, engaging people, understanding, making sure everyone understands the limitations of the tool so they don't see something that doesn't make sense and they throw their hands up and say, well, this whole thing doesn't, I shouldn't use any of it, right? So, clear engagement of your scope at the beginning, making sure that you're engaging people along the way, and then, kind of proving it out is a key.
Makes sense. Thank you.
Great. Any more questions from the floor? Nobody queuing up at the mic? If it's that bad, we'll just take one of these mics and we'll start passing them around. Okay?
So I had a question for Elijah and Alyssa largely. In terms of, I think the training component in terms of what you guys developed is really important. I'm interested to understand a little bit more about that. How long did it take? You said you had a variety of people. Have they continued to use it now after the training's finished? And because I think that's something that's a bit unknown when you go into these projects, is how long will it take for it to be adopted? And is that an easy task, or is that something that requires ongoing work?
Yeah. I can start, and you can maybe talk about the future. So at the outset of this, we had our initial conversations. We were talking about, what we wanted to accomplish overall as far as a goal. And so we kind of mocked some things up, and we had several workshops called like functionality workshops to kind of walk through the tool and make sure. I think we rotated through. We went out with staff and had both like large and small group meetings so that we could try to engage with everybody who'd be using it. So we could get the different shifts and talk through, let people get their hands on kind of a prototype of it to see, get their input, make sure things were in the units that they were familiar with. We were calling things the right names, and that they were seeing the things that they were interested in learning. And so I think that engagement piece at the beginning was important. But then we also developed training modules, more from like a theory standpoint, that we could, have a little bit of instruction, maybe kind of in a classroom kind of setting about, nitrification, denitrification, and how that's a shift from what they were doing previously, but then letting them also use the tool to kind of play around and understand things. So that was kind of our process, maybe from our standpoint, but Elijah can speak to the use of it, I guess, moving forward.
So, and all of that, I think, was about a year and a half process, I think, as far as with the actual project. Going back before that, and I've been at TZO as the manager for almost 8 years. After the first or second upsets, as you would have an upset, you would go back, and if you work with your process engineer, they can go back into the main model that they use for design and sort of recreate what the problems and issues were. And so from an early time, probably maybe 4 years back, I was saying to Paul Pitt, who is one of our process engineers, I wish there was something that we could use from an operational side, even before I knew admittedly what digital twin was. And so, as it came forth and we started looking at this, and were able to use it um, from a training tool, my mind automatically sparked up and said, this is not going to be a one-off just training, but this is going to be part of our culture, part of what we do moving into this new process. So we do, I won't say they use it every day, but they do occasionally as they look at different changes and stuff. My superintendents, my shift shift supervisors will use the information, and as we're switching from different processes, going from 3 stage to 5 stage, 4 stage, depending on what's going on. We had a plant upset about 3 weeks ago, and so we were able to look at, as we're trying to get back, how can we get things set up, and what are our predictive once we get all the way back to normal. um, that's been a tool that I've been glad we've gotten. Where I see it going is, like I talked about before, with chemical usage, with trying to optimize now and not just learn the system, but really dial down, our, our, getting our nitrogen removal down and getting our phosphorus removal down. This tool is going to be even more important to help us with that, and to exchange the data and stuff so they can keep it updated so that we can use it. I think it's going to be a great tool, and we'll continue to build off of it. And I think there was was a comment earlier about taking small steps, and I agree with that. But I think the biggest thing is whatever steps you're going to take, make sure that foundation is solid. Hazen was able to create a solid foundation for us, so whichever way I end up going, I think they can support us because we have a really good foundation with the initial model.
Great. So probably just got time for one more if there is one, but I do have one because Jen's come all the way from Australia and it's 4 o'clock in the morning, something like that there.
Are you saying it's time to have my nap?
No. So obviously we're talking about digital twins here. So and you're the only person probably on the stage that hasn't built a digital twin or created a digital twin. So the question is, what's stopping you from doing that?
Because I don't think we've really articulated what the value is yet, what outcome we're looking for. Agnethe, you talked about process. Actually, process is a really, really big part of it. So understanding what we're collecting data for, how we're collecting that data, what we're going to do with that data, and then how we're going to make decisions. That is all process and people. The system itself will be told what to do. So I think for us, it's finding the right opportunity, finding the right instance to do a little test, and not being afraid of trying to make the wrong decision. I think that's a really big thing. One digital twin to rule them all, or many. There are some big decisions to be made, and I think they're probably the things stopping us.
Great, thanks, Jim. So we're near enough on time. One of the things just to gauge is, did we get a result off our poll?
We did, kind of speak loudly. So thank you for those who responded. We got 15 responses. Out of those, only one said they don't know, and one said no. Everyone else said yes.
Great. So the majority of us in the room trust the insights from digital twins. And so that's great. And hopefully you found the panel insightful. And can I just ask you really just put your hands together and thank these guys because they've been